Our speaker was first licensed 49 years ago and has since practiced his CW from the AR New South Wales broadcast. He runs a group at the Chatswood Library Building, microcontroller gadgets, particularly for the younger generation who have an interest in this area of electronics. The collinear provides gain so wide your coverage map looks like it's been steamrolled. The trick is in the mounting. Members, please welcome VK2EJH, Erik Houseman.
This is a little app I built in 2,500 lines of Python code that took me 2 days using AI that takes the raw data out of this dongle with RTL, SDR, you're probably all familiar with. That data goes onto a web page. The Python code spins up another web page and talks to the original web page, and then it plots the result on a map and it tracks planes on the map. I'm starting to feed back a bit, which is a bit of a worry. Originally we're talking about the Yagi antennas. I've had a couple of goes at trying to build Yagis. I did a loop Yagi using brass from the hobby shops, and instead of a straight element, it's a loop, and you feed the bottom of the loop with the proper coax, and that worked really well. But I tried to build a Yagi just using straight elements. I couldn't get the spacing right. It was really quite dreadful, but they called it a Barbie antenna because it looked like one from a doll's house. This is a slightly different approach to 2.4 gig. We had a biquad, remember these, with a little reflector on the back? That was feeding a Galaxy antenna dish at Currajong grass carts to a similar arrangement, and then a couple of these back to back, just mounted on a TV antenna mast, because you can put a couple of those U-bolts on there and bung your pole in, and off you go. You feed that. That worked really well. But I digress. Let's get back to... I don't know if you call that a collinear, but I thought it was interesting to bring along anyway because it works really well.
How's it fed?
How's it fed? Good question. It's got a quarter wave on 2.4, I think it's this big. It's an N-type connector with that little tiny wire piece sticking out into the cavity at the right space from the bottom of the cavity and from the back plane of the cavity. And also has 2 metal tuning stubs here to help with the tuning as well, but I didn't tune it, someone else did that for me, which was quite good. But other collinears. This is the one that I built specially for today. And I'll show you the calculations for that in a minute, but I'll start passing it around. Basically, you stick it in any old conduit, stick a cap on the top, probably leave it open at the bottom, but stuff it full of cotton wool to stop the bugs getting up. That way condensation gets out and the bugs don't get in. That would be my plan. Just quickly, that's a normal transmission line. I put a PL259 on there with a adapter to SMA, so then that goes into the pigtail. And what I would probably do is have a very short pigtail into the SDR dongle, and then use the USB cable as a long run back to a laptop. And the reason for that is at over 1 gig, this is ADSB, which is 1.090 gigahertz, you get so much loss. So if you get your little receiver up on there, that's all good. So I'll pass that one around. That's half wave, 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 that's half wave. But that's half wave at 0.66 because it's RG213 and the velocity factor of 213 is 0.66. But because this is in free space, that's a quarter wave in free space at the same frequency. So that's a half wave, that's a quarter wave. When I built it, it's slightly off. It was it 995? Where is he?
995. Yeah.
995 instead of 1.090. So a little bit out, but it's a receiver. And lesson learned. Next time, I'll build one smaller. So the other lesson learned from it is, whatever you do, don't start without the proper coax cutter or stripper, because it's such a pain to ring bark it and then pull it all out. When you've got the proper tool, you can just go spin it around and pull it off, you're done. So What's a collinear antenna? You've got multiple radiating elements and they stacked on top of each other, and when you have a dipole antenna, you can picture it as a donut, and the idea of the collinear is you're squashing the donut pattern. So you're pushing your radiation out and you're not beaming up in the sky, which is sort of counterintuitive because you're saying, well, you want to listen to planes and they're up in the sky, but where you really want the strong signal is when they get down to the ground and you get all the ground clutter. So you decrease what's going up into space and you increase what's hanging around the ground, and you're all good. There's different types of them. The one that we're doing here is what they call the COCO array, because it's just bits of coax, and you're changing the phase because you're taking the braid to the inside and the outside to the braid. There are other different types of collinear antennas you can have. There was one on the desk here. It's just a straight piece of wire with the coils. If you keep going that straight piece of wire, another coil, straight piece of wire, that's, you've got a Franklin, it's a version of it. Bandwidth and matching. The more segments you put on, the harder the tuning gets and the less bandwidth you have, and the more problems you're going to get being off frequency. So with mine, I think originally I was going to have a few more segments, but I got kind of bored trying to get all those little bits of wire cut without shorting it out. And I didn't want it too narrow banded, and I was hoping for a little bit more tolerances to my cutting. So I think it worked out fairly well. Here's typical radiation patterns. So the idea is we want to really try and squash it out. So the more segments we put in the antenna, the better the antenna part's going to look. And this is a sort of idea of phasing, like beamforming antennas for Wi-Fi. They use a similar idea. We've got multiple transmitter sources. You combine them all together and you phase it right, and it builds a wavefront out in front of it so that you get a stronger signal. Applications, well, anywhere you want an omnidirectional pattern that's squashed. So if you're looking for aircraft or repeaters on good locations, I was going to say on a mountain, but you're limiting signal going straight up, which is never going to be useful. So it's still useful for repeaters, even though you're squashing a pattern, there's still some signal goes up or down. Construction, let's make one. So the little quarter wave whip at the top is in free space. So you don't multiply the velocity factor is 1 because it's the speed of light here, but it's actually slower in the coax because it's 0.66 for RG213, or 58 I think is 0.66 as well. What we want to do is get each one of these to be a certain length on each segment, and you just keep multiplying it out, and then you have a separate length difference here at the whip. So I don't know if people like formulas, but I'm going to have to not avoid this one. So for calculating the half wavelength, you've got V being the velocity factor of the 213, which is 0.66, multiplied by the speed of light, which is not 300, it's 299,792, close enough.
458.
Yeah, something like that. And the frequency that on this example was for 2.4 gig, 2.441, but I don't want it for 2.4 gig, so the 2.4 gig calculations here are in red, and my calculations for over here you can see is 1090 or 1.09 gig, works out to be there, and the 2 is the half wave and the 4 is the quarter wave. Quarter wave in free space I need about 31 millimetres. Sorry, that's at 2.4 gig. For 1.090 we want 69 millimetres. And we actually pruned it this morning to bring it down. So you'll notice it's not 69 at the top, hoping that would bring it in. And it sort of helped a little bit, but it's still at 995 instead of 1090. So missed it by that much. So first task when you're building one, work out what your velocity factor is. And you just go to any website, it'll tell you what the velocity factor is for your brand of cable. For my one, I suggest you cut it 101 mil chops because it gives you 6 mil either side of the bit in the middle and a little bit of chopping room, because if you're chopping through, you lose 1 or 2 millimetres. So if you start with 100, strip off 6 millimetres, build a segment 87 millimetres long, and then get it exactly spaced when you join it up by using a vernier caliper and lining up. The critical part is to get it all to be the right length, obviously, but starting at the top. Going down, if I set that to 90, close enough, then that theoretically should be from the top of the coax down to there, meets the top of the coax on the next one, and then top of the coax to the top of the coax, top of the coax down to the top of the coax, top of the coax down to the top of the coax. So each segment should now be 90, and that was my theory. And you can measure, you can change it, because if you notice on the top one there's no gap, and on the next one there's a big gap. So I wasn't very good at my cutting, but I got better as it went along.
So
But if you've got a proper cable stripper, it makes the job
You did 6 segments,
a million times
although your
easier.
calculations said for gain,
Yeah.
4 is enough because you don't get more bang for buck.
Well, the original one was 8, and I made it 6.
But that was your choice.
Yeah.
Yeah, it was the 4. They're saying the gain, it's not worth going past 4.
Yeah. I was. I weighed that up against the original plan, which was 8, and I went,
Oh, I see, okay.
I'll do 6. Doesn't really matter. Everyone has their own ideas. Now, there's other different plans too. Some have choke ballons on the bottom, and some have sleeves and choke ballons, and some just have sleeves, and some have a wire that shorts the bottom here to the top of this one, and they call that a ballon. And some of them I've seen where they've shorted the screen to the tip at the top here. I'm going, really? So anyway, I chose to do it my way, and I've read up on it, and they said, it's close enough. If you've done your job properly, that should be 90, and then 180, and then 270, 360, and so on. So you don't get cumulative errors if you've done it right. And I've already showed you this one. Don't start without the proper coax stripper. Oh, and I made a note here, it even works indoors. So I've got the plastic chair out there, and I cable tied this to it and sat it in my lounge room, and I got a distance of 273, but bear in mind I'm on a lake and the plane's way up in the air out at sea. So I consider that pretty good. I do tend to lose the planes when they get to around Bankstown from my place at, well, I'll show you my place, because I actually had the program here running, I think. Let's see if it's running.
It's okay just lying on the table?
Well, it should be vertical. Let's see. It's picking up no aircraft. It's picking up one aircraft with position information. So this is a program I wrote over the last couple of days. So it's still a work in progress, but I'm pretty happy with the results. I've got a home location, so it zooms into my place, and I can set an alarm around it. Or I can choose Amateur Radio New South Wales. You might be familiar with that place. If I zoom in, you can see where the centre of the world is. And I can set alarms for if a plane's going to cross into my alarm zone. And we're not picking up many planes by the looks of things. We've only got 2 aircraft.
We're a Faraday cage for a start.
Maybe we should... Yeah, we're in a metal box, and we're not vertical. I don't know if doing this might help. Holding it vertical. Maybe not. Oh well. But wait, there's more. I do actually have some pre-prepared over in this other directory. This is an ambulance I saw coming over last night, and I compared it to this one, which was the Flight Radar 24 site, and I thought, yeah, pretty reasonable.
Big green dot was your place, mate?
No, that's the aircraft, because I haven't worked out how to draw an aeroplane in HTML yet. If anyone knows how to draw an aeroplane in HTML, let me know. Thank you very much. This is just random planes. The black dots are actual signals received, so you can see that it's getting out. These are, as you can see by the labels, that's 150, so that's 200k. So it's about 250k to where this plane was first noted from my place. What else? This is a typical message string. I digress here, it's not antennas, but anyway, you might enjoy it. This is a typical message. There's different message formats for planes, and some of them give you the vertical rate, and some of them give you lat long, and so on and so forth. This is an aircraft that I found that was a police Cessna. last night, and I noticed that if it was heading anti-clockwise, I got position reports, but if it was turning clockwise towards me, I didn't get position reports. So I'm suspecting that the aerial is on one side of the aircraft and the aircraft is blocking the signal. So that was interesting to me. And this is the same antenna pattern on Flight Radar 24, and you can see these are proper circles. On my one, the top half of the circle's missing because it's been shielded by the aircraft because my house is in the middle of this red circle.
The flight radar's getting it from multiple.
It's getting it wrong, yep. So it's cheating. The other thing that's handy with the RTSDL, you can plug it in and just put a normal SDR receiver in, and that's what an ADSB signal looks like in the RTL software, and that one's RTL Studio, and it's better than a lot of stuff that I've found. So the end result. So you've got an antenna feed line any length but as short as possible. Is that a contradiction? I'm sure it is. Quarter wave or half wave stubs, and at the end, usually a quarter wave stub at the end. And don't forget that it's free space. So we go back to calculations again. It's a fourth because it's quarter wave, and that's my frequency, so that's where I get 69 millimetres from for that stub. And for the other one, we're doing a half wave and same velocity factor, same frequency, and it ends up at 90.07. So, any questions?
You'll still have some velocity factor affecting on that quarter wave because of the insulation is still around it.
It's bare. It was just the inner copper with the thing stripped off.
Showing it. That one's like, yeah, that one's there, the diagram, the picture there had, still had the insulation on it.
Oh, okay. Oh, well, I did it properly. Didn't need that bit of insulation. I was hoping that pruning this would bring it up in frequency. It sort of did a bit, but I think what I have to do is I have to prune every one of these to get it to go. So next one I build, I'll multiply by the difference in frequency between 995 and 1090, work out what that ratio is and make the next one according to that, and then publish it and say, hey, if you want to build one for ADSB, this is the way to go. If you've got this number of elements, presumably two.
Just build a whole bunch with different size, with the same, with different size ones in that.
Okay.
I've got an 900 meg one here, I've got a 1000 meg one here, and I've got a...
Yeah, well, we're talking about, what's it called, that rack thing? The LoRa and the data network that you use?
Reticulum, yeah.
Reticulum, sorry, thanks, yeah. Well, I was thinking of LoRa, but it's got to go way down in frequency from that. But I could do the next one I build will be for LoRa, because I've got a LoRa gateway at home, and the antenna's this long, with a magnetic thing on the back that sits wherever you want to stick your magnet. I thought, well, with one of these up on a pole. Oh, I also mentioned mounting. They can go in this pole, but then this pole can go in another pole, and that can get strapped in the balcony and poke out way above my roof. And that'll make it so much better, I hope. But I was surprised how well it worked inside my room. I mean, we only got a couple of aircraft here. Well, I don't know if we got more now. We might have spotted a few more since. Oh, we've got 7 aircraft now. Last night it worked. Well, I redid the whole code just, and it hasn't really recovered.
Yeah.
It was showing only one with data.
Oh, only one with position. That's why I can't find it, because I can't find where to put it on the map, and therefore it's not on the map. Thank you very much for pointing that out. But I can click on the aeroplane that we do find. Oh, it hasn't got a registration. That doesn't help either. If I had real planes, I'll be able to click on that, and then it jumps into this here, the plane spotter, and it'll tell you what sort of plane it is. And it even gives you a picture. I thought that's really cool. And that took no time at all to build as well. So that's a Virgin float and it's out there. We're not quite sure of its position, but we can hear it. And that's the alarm gone off because the plane's gone into that circle of where we are at Dural. So we go back to the map because it must have. Do you like my clunky alarm? Sounds terrible, eh? Why is that scroll? Enable alarm off. Okay, so there he is there. There's a plane here in Hornsby. Let's go and have a look at him. That's what we've got at Hornsby right now as we're speaking. So it looks like we're off to where? Seoul, Korea. Who would have thought? Let's go back to this one. And it's at 11,625 feet. It's heading at 85 degrees. It's doing 336 knots. And it's 7.6 kilometres away from this very building. So there you go. That's my talk on collinears. I hope you enjoyed it.